All right, here we go. We got chapter 3 review. So this is all about absolute value and inequalities, kind of those weird situations that come up that we have to kind of deal with, a little linear regression. So here we go. Number 1, write an inequality for the graph below. So I'm looking at this thing. First thing I need to do is I need to get an equation of a line. So I need to know the slope, and I need to know the y-intercept, which I should be able to get from the picture. So I know it's always in the form y equals mx plus b. I'm not going to put an equals though because I know these are inequalities. So I'm going to have y and I'm going to have x. Well, my y-intercept is right there at -2. So I know that. My slope looks like it's going up 1 over 1, up 1 over 1. So it's just 1x. And now I see that the line, so now I have to make a decision. Is it going to be, less than or greater than or less than or equal or greater than or equal? Well, one of the things are, when it's less than or greater than, it's going to be a dashed line. And if it's one of the equal to's, it's going to be a solid line. Since this is solid line, I know it's going to be one of these two down here. And now I actually have to pick a test point is one way. I can choose a test point and plug it in and see is it greater than or less than. I do know the equal to part. But let's choose a test point. And whenever I can, I always pick 0, 0 because it's easy to plug in. So 0 compared to 0 minus 2. Well, the correct symbol that goes there, 0 is bigger. So I know that this should be greater than. It's equal to because of the solid. So I believe this is going to be the correct answer. Now, the other thing is, you can kind of use a shortcut. If it's greater than or equal to, you're going to shade above the line. So since I know this was shaded above, I know that it was going to be greater than or equal to, as long as y is in front. If it's less than or equal to, it would have been shaded below. All right, number 2, moving on down. Same idea. So I'm going to get my y and my x. Let's figure out the intercept. The intercept is at -3. Slope here, I got to find some lattice points. So going up, it doesn't look like it crosses perfectly until right there. So this one looks like it's going to be a fraction. So we're falling as I move to the right. So I'm going 5 and 3. So this one looks like my slope is a -5/3. And again, I'm going to choose a test point. I'm going to choose 0, 0. Actually, right now, I can just tell you that because this is shaded below the line, meaning that our shade area is coming down in this direction, I already kind of know this answer. It's going to be less than, and there's not going to be an equal to because this is a dotted or a dashed line. So I know this is going to be it, but maybe I'm unsure. So I do that test point. I put 0 in, and that would be 0, take away 3. And 0 is bigger than -3. So what did I do wrong? Let's just look at this. So I peek at it. It's definitely shaded below. I put 0, 0 in, negative slope, negative intercept. All right, number 2 here. So same idea as up above. I'm going to bust out my y-intercept, which is right here at -3. I look at my slope, which it's coming down, so I know it's a negative slope. And I got to find a couple lattice points here. So I have one at my intercept. I'm going to go up, up, up. It looks like the next one doesn't occur till here. So it looks like we're falling 5 and we're running 3. So it's going to be a -5/3 x. Then I got my y here, of course. And I already know the answer to this one because since we're shaded down this way, it's going to be less than. And since it's a dotted line, I don't put the equal to bar. But I could also just try a test point to check it out. I can put 0, 0 in there. and I get 0 less than -3. And that is a false statement. 0 is not less than -3. So I wouldn't shade the 0, 0 side. I would shade the other side. So you can always do a test point. It's just faster to do the less than or greater than. All right, moving it down to number 3. I have a story problem here, and all I need to do is write an inequality. So I just need an expression, an equation down here. So I have a $200 gift card to Argo Park. It's down in Ann Arbor if you've ever been there, for boat rentals. You can rent kayaks at $8 per hour. Kayaks at $8 per hour. K is kayaks. And you can do canoes for $12 per hour. And C represents the canoe. And then realize my money. I mean, this is all I have to spend is $200. So when I go to rent these things, I better keep it less than or equal to $200. So that's all the money that I have on this gift card. And then I need to write an inequality that's going to figure out the hours. Well, I just got to kind of set that up. So it's $8 per hour times every kayak. And then I'm going to add the price of $12 per hour times every canoe. And that needs to stay at less than or equal to $200. So this would give me all the possible combinations that would work to keep me under $200. All right. Number 4, this we're going to need a graphing calculator. The data below relates the steps per second to the speed for a group of top female runners. These are distance runners. Use the stat function on the graphing calculator to do your linear regression and write an equation for best fit. Then we got to find the R value. Then we got to use that equation to make a prediction. So I'm going to pull up the old graphing calculator here and kind of show you how I punch this stuff in. Yeah, it's a little bit big, so I'm going to shrink it down for us. All right. And what I'm going to do, so in order to enter, first thing I have to do is I have to enter this data. So maybe I'll put some kind of steps up here. So step 1 is going to be, we need to go to stat, edit. And this is going to allow us to enter our data. So kind of show you how I'm going to do this. So I go over here, I click the stat button, and it's already on edit. So I just hit enter. And I have a couple lists. Now, if you have numbers in the list, I'm just going to pretend we had a couple numbers in here because you didn't clear it out after last time. To clear out the whole column, you just arrow up and then hit clear, enter, and that'll wipe out the columns. Go all the way to the top, hit clear, enter, clear it out. Well, now let's enter these numbers. So always on these tables, you have the top is going to be our X, the bottom is going to be our Y. So we have an L1 and an L2. So let's start putting our values in. And you could, if you want to, you could stay with me, or you could actually speed this video up a little bit. But here we go. I got to do 15.86, enter, 16.88, enter, 17.5. Apologize if my pen clicks are coming through too loud, but I got to tap the screen a bunch of times to enter these numbers. 19.97, 21.06, and 22.11. Enter. All right, then I arrow over to my Y values, or my list 2, 3.05, enter, 3.12, enter, 3.17, enter, 3.25, enter, 6, 3.46, and 3.55. And you should double check and make sure you have an equal amount of X and Y values, or else you're going to get an error. All right, so step 1, we've done our duty. We've got that in there. So now I'm going to come in and I'm going to go to step 2. So step 2 is where we want to do stat, calc, and then you're going to choose number 4, which is linear regression. All right, so I'm going to go back to my calculator. I'm going to do stat. Now we don't want to edit the list, we want to calculate the list. I'm going to go down to linear regression, hit enter, and just hit enter again, all the way down, and boom. So I have my A and I have my B, which is fine, but one thing I don't have is I don't have my R. So I got to make sure the diagnostic is on, and I guess on this online calculator it turns off every time. So if you're not getting the R values, you need to go to second zero, which is your catalog, and you need to go down to the D's, diagnostic on. If you just hold it down, it'll go there. There's a faster way, but I'm not going to mess with it right now. It was in the video notes. Diagnostic on. Now I'm going to go back to stat, calc, number 4, and hopefully this one is going to show me the, there we go. Now we got our R values. Sweet. So I'm going to come over here and I'm going to write these in. So our equation is y equals, well, they're using A for the slope, and I said round to the nearest hundredth, so it's 0.08. 0.08. And kind of be careful, because I think on the first copy I sent out I put the nearest tenth, but it wasn't really accurate enough when I did it, so I'm going to tweak it a little bit. And then I'm going to have my x, and then my b value is 1.77 if I round it properly. So now I have an equation that can predict a bunch of other values that aren't in the table. And my R value is right here, which is super correlated, which means if I were to graph this stat plot and then graph this line, almost every dot's going to be right on the line. It's so close to perfectly 1. So that is 0.998. And I'm not going to round the R value, because if I round it to 1, that means it's perfect. And it's not quite perfect, but it's pretty doggone close. This will be a multiple choice or a drop down on the test. So don't really worry about how many decimals to go. You'll see it match up. Now, use the equation to predict. Whenever you want to predict, I'm going to use this equation. And what we do is we know the speed. We need to find the steps. So basically, we need to find y, but we know the x. So let's put 18 in right here, and let's calculate it. So y equals 0.08 times 18 feet per second, because we don't have that in the table. We have like a pretty close value. So it's going to be close to that. But then I got to add 1.77. So let's just punch that in our calculator really quick. 0.08. Actually, I'll just do this off on my own little calculator so my graphing one stays up there. 0.08 times 18 plus 1.77. We're predicting roughly 3.13 steps per second. There you go. So we've actually been able to model the data and now make a prediction with the data based on our linear regression equation. All right, next problem. Going down to number 5. The equation of the line for the best fit is, so this is basically like you've put all the data from some problem into a calculator, and it did the linear regression for you, and this is what spit out. And so now we need to know, what is a possible R value? We know nothing about the data, but we do know what that line looks like. So the first thing I want to kind of focus on is, we know that the best fit line is negative. It's a negative line. So, and it's got an intercept at like 52.7. So we're way up here at 52.7. We're dropping at almost a -1. So that's our best fit line. So we have no idea right now, no idea at all where the dots are. The dots could be really loose. They could be really tight. You know, we have no idea. But we don't really need to know that to answer this question because there's some things we can rule out. So the first thing is, an R value can never be bigger than 1, and it can never be less than -1. So that's the first fact you need to know, is that it's never more than 1, and it's never smaller than -1. Those answers can be eliminated. Now, the next thing we know is, if our best fit line has a negative slope, that means our R value has to be negative. So that wipes out this person. So on this problem, that's the only feasible answer. Now, if I would have had another negative between 0 and 1, it would have been an impossible question. There would have been 2 possibilities. So that was just testing, do you really know the boundaries for R? All right. Number 6, which of the following best describes the correlation shown? Well, this isn't a great graph, and I kind of purposely made these a little bit kind of weird. But the data definitely is kind of trending down as you move to the right. So I know it's negative. And they definitely don't stay tight to a line. So I think this is a weak negative relation. Number 7, we have a scatter plot doing the height and the weight, the height and the length of the humerus bone, which is between the elbow and the shoulder, kind of like your bicep and tricep area. And this is like archaeologists. They find bones and they record the data, and then they kind of make predictions about like how big people were, you know, back in the day and things of that nature. Or like a murder where they find bones that are, you know, 20 years old, and they're trying to figure out, could it be a certain person? But somebody's done a scatter plot. Somebody's done the regression. We actually have an equation here that was built that we can use. So it just says use the linear regression equation to plot on the plot to predict the woman's height if the humerus was 32. All right? So the humerus is 32. So, you know, as a guess, this isn't the answer to the question, but as a guess, when I look at the chart, it looks like we're going up by 2s on the scale. So 32 would be right here. So I'm predicting it to be somewhere around 160. Now, because there's a bunch of decimals in this equation, it's probably not going to be exact. But if I get an answer too far away from 160, I'm going to be kind of concerned. So H is 2.75 L plus 71.97. And we found a bone that's 32 centimeters long. So H is going to be 2.75. And my 32 is going to get dropped in right there because that's the X value, or the L value in this case. H is over here. And I got to crank it out on my calculator. So I'm just going to punch this in really fast. 2.75 times 32 plus 71.97 equals, and I get 159.97. There we go. And again, don't worry about your rounding. It says round to the nearest tenth. So that would actually tell me to go up to 160. So the answer for this one did end up being 160 when I round it. All right. Usually the decimal problems, I do drop downs on the test just so it takes all the shenanigans out of there and makes it really easy. What is the equation of best fit for the scatter plot below? So pretty tight line. We don't need to know anything about R values. This was actually an SAT question that I ripped off one of the practice SATs. Well, a couple things that I see here. One thing is I'm looking at all these lines and I'm looking at the slopes. Remember, slopes are what's in front of the X. And I notice I have some positives and negatives. This line definitely has a positive slope. So I can get rid of these lines with negative slopes. You're out. Now I got to double check, and I got to look at the y-intercept. You know, the y-intercept is somewhere very close to 4, 3 point something, something, something. So this looks like a good y-intercept. And this is not the y-intercept. That would be down here somewhere. So looks like the correct answer is A. The only weird thing on this one is they kind of wrote it in y equals b plus mx form. So they kind of did their starting point and then the slope, which actually I wish all books did it that way. It just seems more intuitive to start at b and then start sloping up from there, but I don't know. I don't get to write all the books. Moving on down, number 9. So now we're just getting into the grind part where it's just straight up solving algebra. So we have an OR inequality. So this is an OR problem. And I know most OR problems, they either blast out in both directions or possibly just in one direction. As opposed to if we stumble across later on an AND problem, all right, those are going to be the barbell kind of looking things. And so that's something we got to kind of keep our eyes on. Well, let's just solve this. So I'm going to add 10 to both sides. And I get 2x less than or equal to negative 22. Divide both sides by 2. So I need an x is less than negative 11. Well, right now, since this is multiple choice, B looks like the only one that has that. But we'll do the other side too, just in case. So I look at the other side, I minus 1, 3x greater than or equal to 9, divide. X is greater than or equal to 3, and boom, checks out. B is the correct answer. All right, moving right along, number 10. So which of the graph is the solution for blah, blah, blah? So another OR problem. Right now, all of those look like they could be fair game because there's no barbells. So let's just kind of go in here and see what we got. So this one, I'm just going to divide both sides by a negative. Be very careful. When you divide by a negative, you got to flip-a-roo that sign. So I got a is less than or equal to negative 2. I do the other side, and I get a is greater than or equal to 6. And now we got to graph those. Well, less than or equal to negative 2. There's two possibilities for that one, because this is less than or equal to negative 2. This is less than or equal to negative 2. So that wipes out these guys. Remember, it's a solid circle because of this equal to bar. That makes this solid. Now we got to be greater than or equal to positive 6. So A does not have that. B does. So it's looking like correct answer here is D. Number 11, little absolute value action. So remember from the notes, we always want to get the absolute value brackets by themselves and then solve the two cases. So to get it by itself, I got to first minus 7, which will give me the absolute value of 2x equals 6. And now there's two cases. You drop the bars and solve it as is, or you drop the bars and you do the negative of that answer. And dividing both sides, I get x equals 3 or x equals negative 3. So two possible answers could go inside there, and you could test it to check it out. I'm not going to do that, but you could. Number 12, similar idea. This is an equal to, so same setup. I got to get the absolute value by itself. So I need to get rid of divide by 3. So if I times by 3, bam, that immediately gets rid of that. But then I have to times the other, whoop, started doing the math in my head too quick. I got to times the other side by 3. So I'm going to have the absolute value of x plus 5 equals 6. So let's solve two cases. Solve as is. Solve for the negative. And minus 5, I'm going to get x equals 1. Or if I minus 5, negative 11. Boom. So going on down, number 13. Go in here, pop this joker in. All right, number 13. What do we got here? So I got to get the bracket by itself. So I'm going to minus 9 from both sides. And I get 3p minus 5 equals negative 4. Right now, stop. All right. If I can draw an octagon. Attempt to. I'm out of geometry mode this year. But stop right now, okay? Why I said stop is because that's a violation, okay? Once you get the absolute value bars by themselves, once you're all alone, I don't care what is inside here, blah, blah, blah. You can never be a -4 because the definition of absolute value is it's the positive of whatever's inside there. It's a distance. -4 is not a distance. So this is a no solution problem, trick question. So be careful. The SAT does it once in a while. So I'm just pointing that out to you. It's kind of nice because then you don't actually have to solve it. You're like, oh, sweet. Make up some ground on time. All right, now notice a little difference here. We have an inequality. So the game changes slightly. It's still two cases. Case number 1, as is. Case number 2, instead of just making the number negative, you got to flip the inequality symbol, okay, and make it negative. So first thing is get the absolute value by itself. So -10, -10. So I got absolute value 1 plus x is greater than 6. All right. Now I go into my two cases. Case number 1, as is, 1 plus x is greater than 6. Case number 2 is 1 plus x. And now is where I got to flip it and I got to change the sign. So I'm going to flip it and then I got to look at the negative version. So similar to equals, but not quite. -1 from both sides, I get x has got to be greater than 5. Over here, when I -1, -1, I'm going to get x is less than -7. So let's graph these. And remember, this is a greater than question. If you are greater than or equal to, that is an or situation. So I kind of know what this graph is going to look like. So I need to do x is greater than 5. I'm not going to shade it in because there was no equal to bar. So there's greater than 5. And then the other side was less than -7. Less than -7. And that looks like an or problem to me. So I believe that we did this one correct. Next problem, number 15. Which of the following is not a solution of, and so this is the way the SAT will kind of work it. Two ways to do this problem. You could plug all those numbers in and see which ones work, see which ones make it true. That might be easier for some of you. I'll go ahead and I'll just solve it and graph it. So I'm going to get just to practice a little bit more. So do it as is. And I get x has got to be greater than or equal to 8. So if I'm thinking about my line down here, and here's 0, I got to be greater than or equal to 8. So I need to be in this area. Those are solutions. Those things work. And then if I got to solve the other case, x minus 5, flip the sign, make it negative, add 5 to both sides. I got to be less than or equal to 2. So right here. So if all the shaded area, maybe I should do that in blue. If all the shaded area are solutions, the area that's not a solution would be right inside here, which any number between 2 and 8. So you are a solution. You are a solution. 3 would not be a solution. -10, you're in the solution. So correct answer there is B. Some of you might choose to just plug the numbers in. It could be faster, but I thought I'd show you the traditional solving it way. Number 16, which function has a vertex? So now we're getting into graphing. So you could go back and look at the 3.4 practice or 3.4 notes. Graphing absolute value. And what I know from the vertex, remember, is like the V point. It's that bottom part, that's the vertex. And the parent function starts at 0, 0. Maybe I'll just use this graph down here while I'm at it. Well, if the vertex is at +5, -2, right, then that means this thing looks like that. So it looks like that I went right 5, down 2. So if you're talking about an absolute value equation, down 2 is the back number. So that eliminates B and D. And then right, remember it's opposite of what you would think. So if we went right, it's actually a -5. So the correct answer here is going to be A. C would have been left. So that's going to put the vertex right there. Number 17, if g of x, and again, I'm going to give you some graph paper for the test. Realize that the SAT does not, so you got to kind of get good at sketching graphs, but I'm going to hook you up in here. So if g of x is a reflection across the x-axis, so I got to be aware I'm flipping across this line, all right? And g is a reflection of f of x is x minus 2 plus 4. So that means that we went right 2, up 4. So let me move the parent function right 2, up 4. And there's nothing in front to mess with the slope. It's just 1 and -1. So this is f. You know, I just graphed the f function. But then it says, hey, g is a reflection. So g means if I reflect this thing, it's going to be right here, and then it's actually going to be going down. All right? So the first big idea is, like, it's got to have a negative in front. So it cannot be u, and it cannot be u, because we had to have that negative in front to flip it. Well, now, if you look at the vertex, we went right 2, down 4. So I'm looking at a -4 in the back and a -2 inside the bars. So it looks like the correct answer here is D. This one had a +4 at the back, which would not have been right. So those are a little bit tricky, man. Higher level thinking there. Number 9, G is a reflection across the y-axis. Which of the following is an x-intercept? All right. I wish I could use this graph. I guess I'll just have to show you how to sketch one real quick. So if I don't have graph paper and it's the SAT, I just very quickly sketch it. These are small numbers, so we're going to keep it to 5. Doesn't take too long. Try to keep it be accurate somewhat. So I'm going to graph the f function. It's this looks like right 2, down 3. So I got to go right 2, down 3, right 2, down 3, and it's going to be going, you know, up, and the slope is up 1, over 1, up 1, over 1, up 1, over 1. This one is pretty important to be accurate because we're worried about like intercepts and what's going on. So I kind of want to be somewhat accurate here. Now, if you have graph paper, it's easy to be accurate, but I don't, so I'm just sketching. And I want to reflect across the y-axis. So on this problem, I want to reflect across this axis. So every point's got to jump across. So that means my new function, the vertex is going to move from here over to here. And then remember what we're trying to find. We're trying to find these new x-intercepts. So, you know, I could try to regraph it, but I could just kind of be smart about this and say, hey, wait a minute. It looks like the vertex moved 4 to the left. So my intercepts should move 4 to the left. And this intercept right here should move 4 to the left. Or you could have plotted them out. So it looks like my x-intercepts are right there at 1, 0, and right there at 1, 2, 3, 4, -5, 0. So 1, 0, -5, 0. 1, 0, -5. Looks like that's D. All right. Another way you could have done that problem, maybe without all the graphing stuff, is once you've seen that the original was at 5, 0, and the other one was at -1, 0, if you remember that when you reflect across the y-axis, basically what you're doing is every xy is turning into a negative xy. You're just changing the x signs. So that might have been a faster way to get your answer, but it's up to you. Sometimes graphing it, I kind of feel more comfortable on. I need to graph this thing, so again, it's just a transformation. So this says go up 3, go right 4, up 3. I feel like I just did that one a minute ago, but maybe it was a little different. Now I have an inequality, so I got to know right now, like just looking at this, I'm like, oh man, because of that thing, I know that I'm going to shade below because it's less than, or I could test. If you like testing points, go ahead and test points. So first of all, let's look at the transformation. I know what the normal v looks like. You know, and you don't have to write this down, but I'm going to write it. The normal v is, that's the parent. Well, I need to do a couple of adjustments. I need to go down 4 because of that minus 4. And then I need to change the slope and make it equal 3. You know, right now my slope is equal 1. So I need to make the slope equal 3 and just go down 4. So we're not doing left or right because there's nothing in parentheses. So if I go down 4, and now instead of a slope of 1, instead of going up 1 over 1, I'm going to go up 3 over 3. Up 3 over 3. Up 3 over 3. 3, 3, 3, 3, 3, 3. Now I think I just kind of got a little brain idea here. It's like, oh man, that's pretty cool. I got a little idea that maybe on the test as one of the application questions, maybe it'd be interesting for me to ask, where are the intersection points for the parent and the transformation? So for you guys that are actually taking the time to watch this video, I'll give you a little hint. I think I'm going to come up with a question for the test that says the intersection between the parent and the transformation. So just a little insider knowledge for you guys that are tuning in. All right, moving it right down. Where are we at? A couple more to graph. I'll try to go quickly because this video is getting long. Got to reward those people that are still here. Solving graph if x is less than negative 4. So x is less than negative 4 is going to be a vertical line dashed because there's no equal to bar. And if I'm less than negative 4, that's this side of the line. Let's go down. Graph, y is less than that thing. So pretty straightforward. Y-intercept is at 3 because of that. Slope is negative 2. So down 2 over 1, down 2 over 1, 2 over 1, 2 over 1, 2 over 1. Back it on up the other way. This tells me that not only do I need to shade below, but it also tells me I got to be a dashed line. So I'm going to use my cool little dash tool here. And then I'm going to start doing my shading below the line. Bam. All right, last two. Let's do this. I got to hurry up. Class is about to start. All right, y equals, so we got a lot of stuff going on here. I see 4 things affecting my parent function. And I'm going to run through all 4 right now. Here are the 4 adjustments. We need to go up 2. Plus 4 means I need to go left 4. This negative sign means I have to flip it. And this 2, whether it's on the inside or it's on the outside, it's going to affect my slope. This one's probably the hardest one we've done. So let's get the vertex first. I always kind of start with the left and the up stuff. So I'm going to go left 4, up 2, left 4, up 2. So vertex is locked in. Now I need to flip it, so I know I'm coming down. And I believe I'm going to come down with a slope of 2. Down with a slope of 2. Down with a slope of 2. Slope of 2. Slope of 2, slope of 2, slope of 2. I think I'm going a little bit crazy making this video. Now, I'd like to check. I'd like to run through here and just try some points on a table. Just, the slope thing maybe makes me a little bit nervous because it was on the inside. And I don't know. I want to just test a few points. So I could test these guys. I could test -3, 0. So if we plug in -3 for x, I'm going to get 2 times -3. Well, that's -6. -6 plus 4 is -2. Absolute value of -2 is +2. But then I got to bring the negative down. Oh man, I'm feeling pretty good. That point's on there. I could pick another point. Maybe I'll pick that point because that's got another 0 in it. Let's pick 0, -6. 0, -6. So I'm going to come up here. And on the test, man, if you have extra time, that's what you do. You test stuff just to be sure. If I stick 0 in, 2 times 0 is 0. 0 plus 4 is 4. Absolute value of 4 is 4. Uh-oh. See, this is why you test stuff. If I put 0 in, absolute value of 4 is 4. -4 plus 2, it's saying I should be at a -2. So when x is 0, it's saying I should be at a -2, which is up here. So this makes me a little nervous. So now I'm going to be like, well, what the heck did I do wrong? So when I'm in a pinch, I'm going back to just the tried and true. I'm going to just stick some numbers in, see what happens. I'm going to do this in red. So I'm going to stick 0 in. 2 times 0 is 0. Absolute value of 4 is 4. -4 plus 2 is -2. So it's telling me I should have been here. If I put 1 in there, 2 times 1 is 2, plus 4 is 6, which would be -6 plus 2. That would be -4. So over 1, down 4. If I do the 2, that's going to be 2 times 2 is 4. So if I stick 2 in there, 2 times 2 is 4. 4 plus 4 is 8. -8 plus 2, that would be a -6. So it's almost like I'm running parallel to where I'm supposed to be. Well, let's go in the negative direction, see what's up. 2 times -1 is -2. -2 plus 4 is 2. Absolute value of 2 is 2. -2 plus 2, that would be 0. So they're saying at -1 I'm at 0. Let's slap -2 in there. That would give me an absolute value of 0 plus 2. So -2 is 2. Go to -3. -3 is 2 times -3 is -6. -6 plus 4 is -2. Absolute value of -2 is +2. Bring the negative down. And I get 0. So -3 is 0. So what in the world did I do wrong? So I know for sure that this red line is the real answer to the problem. So I have to ask myself, where did I go wrong in the beginning? So it looks like when that x is in the front like that, when you have a number in front of the x, it is the slope, but it does mess with the left and the right. It does mess with that. So moral of the story is this: if that number is in the inside, you cannot still just use your little cheat code. And so sometimes it's nice to kind of check it with a table. That one's kind of tricky. I'm going to have to mention that in class. And number 24, the old triangle one. Let's kind of see what this is talking about. Graph a triangle that's below the x-axis and above the graph. So let's do the graph. Absolute value is down 6. slope of 1/2, up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. Oh man, I'm going to have to extend this out. And I better extend it out over here. It's probably going to do that as well. And another up 1 over 2 would put me right there, which is going to be at 12, which means the other side is going to be over here at -12. So I'm not going to be too careful right now. So there's my triangle. And I need to graph the triangle that's below the x-axis. So I got to be below this x-axis. So basically they're wanting me to figure out what's this area. So remember, area of a triangle is 1/2 base times height. So this is the base. This is the height. So the base is going to be 24. Height's going to be 6. So 1/2, 24 times 6, which is 12 times 6, 72 square, whatever those units are. All right, man, I finished right on time. This was a long video. Thanks for watching. See you.